So what's the next line?
Um, 5x squared minus 8 equals 4x squared plus 12.
Next line.
X squared equals 20.
Next line.
X equals plus or minus square root of 20.
Very good. And that's the only variable. So the only trick there was to make sure you picked up the plus or minus. It's the only way anybody's making a mistake on that problem, is to forget the plus or minus. All right, C. Hold on a second. Let me move this down a little bit so that I can get more writing room. First step on C.
To subtract 3.
What's the second step?
Divide by 2.
So now I have this. Now what?
2x minus 1 equals 5, and 2x minus 1 equals -5.
Alright, we don't need to go any further on that one. I know you can solve each of those. On D, what's the first step?
Subtract 10.
What's the next step?
Square both sides.
What's the right side?
49.
And what's the last step? I just solved for X.
Plug it in.
You got to plug it in, yeah. Even though, generally speaking, if you only get one solution, there's probably not extraneous solutions. But if I got two solutions, I would definitely expect one of them to be extraneous. In this case, I can see that when I plug it in, I get 9 times 6, 54, minus 5 is 49. The square root of 49 is 7. Ooh, 7 plus 10 is not 3. There is no solution to this problem. And notice why. If we go back to this step, that's impossible, right? In other words, when you take the square root of something, it's always positive. No matter what is inside, the answer is a positive number. And here we've got the square root of something is -7. Well, I immediately can stop right there and say no solution. I don't have to finish it out. And actually, the key kind of was when we squared both sides, that turned into a positive 49. That's kind of a red flag that maybe there won't be a solution. But really the key is to recognize that at that step right there, realizing it's impossible. It's kind of like a 7th grader caught me once. When I say caught me, I didn't realize he gave me this problem right here. Okay? And of course, I did it. Well, x minus 1 equals -1, or x minus 8 equals +1, right? And I worked through both answers, and I got x equals 7 or x equals 9. Well, neither one of them is true. That's because the absolute value of a quantity can't be negative. So I should have picked it up right there when I saw it, instead of just barging forth with the algebra. In other words, you can barge forth with the algebra like I did, and come up with what looks like answers. That looks like an answer, that looks like an answer, but neither one of them gives you the proper answer. It's because the absolute value can never be negative, just like the square root of something can never be negative. So these are kind of trick questions. This D, it's other than this 7th grader from Florida, I've never seen anybody give me that problem, where you get an absolute value problem that doesn't have a solution. So you gotta always be on the lookout for that kind of stuff. What do I do in E?
Square both sides.
What's the next line?
8x plus 1 equals x squared plus 4x plus 4.
And the next thing to do?
Put everything on the right.
Okay. I think we did.
X squared plus 12x plus 5.
I think it's minus 4x.
Yes.
And plus 3. Which is a good thing because now that factors nicely. And you get x equal 3 and x equal 1. And because we're looking at a radical sign, I would expect one of those not to work. Maybe, maybe not. They don't always produce extraneous solutions. And it looks like the 3 works. The 3 does. Square root of 25 is 5. Does the 1 work? Yeah, it does also. So both of them are valid, which is almost unusual. That's more the rare than it is the norm. Alright. Inverses and logarithms and 3 variable systems. How fun. What's A?
27 to the power of x equals 1/9.
Yeah, I always add a variable here because to me it's easier. Once I've added the variable, now I can list this exponentially. So I got 27 to the x equals 1/9. Now what does x have to be?
Negative 2/3.
Really good. Really good. Yeah. That's not easy. I was still trying to figure it out in my head. But that's definitely correct. Okay, the next one.
8 to the power of x equals 4.
It's x.
2/3.
That's a little easier. That's the best way to write that one. What's x?
0.5 or negative 1.
Write the D for me.
10 to the power of x equals 1,000,000.
So what's x?
6.
Always the number of zeros. And E?
6 to the power of x equals 6.
Don't even need to do that. Log base B of B is always 1. Whenever you see it, it does not matter what the numbers are. In other words, log base 17 of 17 equals 1. And it's because 6 to the 1 power equals 6. So it doesn't hurt to do it the other way, but a good thing to recognize is those. Condense the one on the left.
Log base 3 of x to the 1/2 divided by Log base 3.
When you condense it, you turn 3 log expressions into 1 log expression with a big argument. In other words, what goes in the bottom is y to the 4th times 6. And that whole thing is the argument. That's the whole reason we condense, is so that we can take multiple log expressions and turn them into 1 log expression. Now, if this was part of an equation, I might be able to go further. Okay? In other words, that would be the first step in solving the equation. Expand this one, which means, notice we have a single log expression. We're going to end up with multiple log expressions. What's the first?
4 log base 2 of x. Plus 4 log base 2 of y. Minus 1/2 log base 2 of z.
Got it. Okay. Here, let me scroll down. Find the inverse of A. What's the next line I should write?
X and y switch.
What's the next line?
Log base 3 of x plus 2, or y plus 2.
Yeah, really the first step is to replace f of x with y. Then switch the variables. Because when they give you f of x, that's not y. It means the same as y, but okay, now what?
Add 1.
Okay, so I get x1 plus x equals that. Now what?
Cube root each side.
I'm sorry, what?
Cube each side.
Not really cube. What you're going to do is let the left side be an exponent to the number 3, and I'm going to let the right side be an exponent to the same number. Why did I choose 3? Because of that base. In other words, when you take a number and raise it to an exponent that's the log base of the same number, the answer is y plus 2. So what I get on the right side is y plus 2 equals 3 to the x plus 1. And therefore, y equals 3 to the x plus 1 minus 2. And it's not fair to call that y. It's not really y. It's y inverse. But notice, when you find the inverse of logs, you end up with exponentials. If we find the inverse of that, we're going to end up with logs. Just remember that. And the way you get that exponential is by, you know what, do I have to do it that way? I always do it that way because I know that way, but I realize that's not the way everybody's going to do it, huh? In other words, is all you really have to do is convert that to exponential format, which is what?
Y equals AB to the x.
Well, no, exponential format would be the base raised to the other side of the equation equals what's in the middle. In other words, I didn't have to go through that nonsense of making it an exponent to 3. Is all, and I make that mistake every time. I forget that there's an easier way to do it, which is to just convert it to exponential format, which is the number normally on the far left, because the log expression is normally on the far left. And this is where you have to be a little careful with remembering it like that. The way you really should remember is it's the base raised to what's on the other side of the equal sign equals the argument. And you get the answer pretty quick. Same as I got doing it the other way, obviously. And that's inverse y. But yeah, you really don't have to know that secret of exponentiating. I don't know why I can't get rid of that leak. Do this one.
Add 4. Or switch, yeah.
Switch the variables first. And then add 4. So this becomes x plus 4. Now I have that. Now what would you do? Got to solve
Take
for y.
Log of both sides.
What kind of log?
It doesn't matter.
Good. So I'm going to use natural log equals, and then I'm going to bring that exponent down in front in parentheses like that. You see how I got to that step?
Yeah.
Okay. And now it's actually not that trivial. The next step, I have to distribute both of these. Hold on a second. What the heck happened here? I took the log of that, and then I moved that down in front, so I got that. That's just a number. So I'm fine. So if I divide both sides by natural log of 3, I get rid of that. And now I just have to subtract 2 from that answer. So I get minus 2, and that's equal to y inverse. Again, I started with an exponential, ended up with a log expression. Just like if I started with a log, I'm going to end up with an exponential. What am I going to end up with on C?
I don't know.
That's an algebraic expression. I'm going to end up with an algebraic expression. In other words, after switching the variables, I get this. Then I subtract 5 and multiply by minus 3/2. And that gives me y minus 2 cubed. You with me?
Yeah.
On each of these steps. Now, what's the next one?
Factor amount.
Take the cube root of both sides. So I'm going to take the cube root of minus 3/2 times x minus 5. I can take the cube root of a negative number, and that's equal to y minus 2. So I'm going to add 2 outside the radical sign, and there's my y inverse. But notice that it is indeed algebraic. It's not logarithmic or exponential. Suppose we should do one of these. Just to make sure you can do it. I think you've done one before. How are we going to do this one? I'm going to label them. Equation 1, equation 2, equation 3. First of all, am I going to do it by substitution or elimination?
Elimination.
Which variable am I going to try to eliminate?
Y.
y can be eliminated without any extra steps by merely adding 2 and 3. So what does that give me for equation 4?
Um, 2x plus 5z equals negative 14.
Now here's the trick. To come up with equation 5, I've got to eliminate the same variable using 2 different equations. I can't use 2 and 3. I could use 1 and 3, or I could use 1 and 2. Which one should I use, and what should I do first?
Um, 2 and 3 are
I used 2 and 3 the first step. So I got to use either 1 and 3 or 1 and 2.
1 and 2.
Okay? What do I got to do before I can eliminate y?
Times the second equation by 2.
Which is 10x plus 2y plus 4z equals 16. I run a line through it just so I don't get confused. Now, add 1 and 2, that gives me equation 5.
13x plus 5z equals 19.
Oh, how nice. Negative 19. They set it up perfect for us, that we can now solve this system of 2 equations and 2 variables. Of course, you know how to do that anyway, but that's what you always have to do with these. 3 variables and 3 equations is you have to create an equation 4 and 5 that are both missing the same variable, so that I only have 2 variables now. Now what's the best way to solve this?
I would take out z by multiplying one equation by negative 1.
Or we could just subtract the 2 equations. How about we do 5 minus 4? What's that give us?
It's 11x equals negative 33.
Okay, that's one reason we like to add instead of subtract, is because people make mistakes when they're subtracting.
No.
I was doing minus 19 minus a negative 14. That's minus 5.
Yeah.
So your first step actually was probably a better step for accuracy purposes. By multiplying one of the equations by minus 1, we turn it into something that I can solve by adding, and I'm not as likely to make mistakes. But now we get our x solution is minus 5/11. Now what next? We got to solve for all 3 variables.
Put 5/11s in for z into one of 4, 5.
Okay, and to 4, because that's by far the simplest one. That will solve for z. And then once I solve for x and z, go back to one of these originals. Usually the simplest one. I think the simplest one's probably number 1. It's got all the smallest numbers. And I would put in my answer for x and z and solve for y. I might actually use 2. Why would I use 2 as opposed to 1? Because I'm solving for y, and it has a positive coefficient of 1 already. So it's going to be really easy to solve for y. Whereas up here, it's minus 2y, has a negative coefficient, and I'm going to have to do some division. So even though these numbers are a little bit bigger in 2, the fact that the variable I'm solving for has a positive 1 coefficient, I'm going to do that. The math's going to be easier. All right. Nicholas, I can hardly wait till 9 o'clock. This is my last really busy day. I've been having 5-hour tutoring days for like 3 weeks in a row. And tonight is, you're the last session. I've got like an hour tomorrow and an hour the next day and a couple hours next week, which I love. But I love doing a couple hours a day. But boy, I don't really love doing 5 hours in a row. It's hard. So I'm excited. My vacation's almost starting. Don't get me wrong, I love tutoring. I would not do anything else. How am I going to start graphing this thing?
By finding the x-intercepts.
Okay. Let's find them. Not only by finding them, but let's find their multiplicity also. Because remember what multiplicity tells you. It tells you whether it goes through the x-axis or it kisses it. If it's an odd multiplicity, it goes through. If it's an even multiplicity, it kisses. So where's the first 0?
At 0.
Okay. And it's going to go through that. Where's the next 0?
At 7.
And that is going to kiss. So I'll make a little thing like that. Where's the next 0?
At -2.
That, it's going to go through. And the last 0 is at 1. And that is odd multiplicity. So we know the behavior pretty much of this function. The only thing we don't know is the end behavior. In other words, do I start up here or do I start down there? Well, let's figure out the end behavior. What happens when x goes to negative infinity? What are we looking at? First of all, yeah, the way you do these is basically plug in negative infinity. In other words, if I want to know the end behavior, then I'm going to do this. Now, what's that? Is it positive infinity or negative infinity?
Positive.
Okay, so that's positive infinity. That's a negative infinity, that's a negative infinity. When they multiply together, you get positive infinity. So those 3 terms are positive infinity. What's negative infinity cubed?
Negative infinity.
And then I still have this -4 that just sitting out there. That negative times my negative is going to be a positive infinity. Now I got infinity times infinity times infinity. What's the left-hand end behavior equal to?
Positive.
That tells me where to start this curve. And that's all I need. I'm going to start it up here. I'm going to go through the curve there. I'm going to go back through the curve there. I'm going to go through the curve there. I'm going to kiss off of that and end up down there. Now, if my life depended on it, I would check out the right-hand end behavior. But the right-hand end behavior is that's infinity, that's infinity, that's infinity, that's infinity. The negative sign makes it a negative infinity. So that's on the correct side of the x-axis. And that's what the function is going to look like. Now, it is true that I have not figured out how far down that thing goes, or how far up that goes, or how far down that goes. But they don't care about that. They want a rough graph of this polynomial. They don't need to know what these points are. I mean, you know, if this was an important function, I'd want to know what those points were. But if I graph this function in Wolfram alpha, it'll come out looking an awful lot like that. I may have it slightly wrong. In other words, maybe it goes all the way down like that and all the way up like that. So it could have some greater amplitude in the loops in the extrema, but they don't really care about that. The purpose of this question is to make sure you can figure out your end behavior and how it acts when I cross the x-axis, whether it goes through or whether it kisses. So first step on the next one.
Find a common factor.
It's the greatest common factor.
I don't know.
Can't take a number out. Can I take a variable?
X cubed, X.
Just x. That leaves x cubed minus x squared minus 9x plus 9. Now, that's a cubic, which are terribly difficult to factor unless they can be grouped. Can this one be grouped?
Yeah.
What's required for the grouping is that the ratio of the coefficients of the first two terms has to be the same as the ratio of the coefficient of the last two. What have I got? I got 1 over minus 1. Is that the same as minus 9 over plus 9? And yes, it is. That means I can group it. Now what do I do?
I don't know.
I want to group the two terms on the left and I want to group the two terms on the right. Okay? Group the two terms on the left is easy. This part, not so easy. Now, hold on a second. That x is multiplying everything, so let's put it there. What's left? What else can I pull out? In other words, well, first of all, let's write those two terms. You see why I put the x over here?
Yeah.
In other words, that's this x there. I'm merely distributing it to my second set of terms here, rather than using a second set of parentheses. Okay, what can I factor out of the, well, let's write it. What goes inside the parentheses there?
9x plus 9.
Nope. Notice that if I do it that way, I do not have the same thing I started with. If I redistribute that, I got minus 9x minus 9. Therefore, I got to change the sign on that 9 to a negative. Now I got the same thing I started with. And that's vital that you notice that. because otherwise you'll get it wrong every time. And what you're looking for is that minus sign right there. If that's a minus sign, you have to be very careful when you add parentheses to these last two terms. I can't just add parentheses to it. It changes it. If I start with this, if I start with these two terms, and all of a sudden I add parentheses like that, it's not the same number. That becomes minus 9x minus 9, which is not what I started with. I started with minus 9x plus 9. So you always have to remember not to change it, that you end up with something that is the same as what you started with. Now, factor a greatest common factor out of the parentheses on the left.
X squared.
Which makes that x cubed and leaves x minus 1, correct? Now over here, what am I going to factor out from inside the parentheses?
A 9.
Leaving x minus 1. Now, if you've done these properly, you'll always have those two terms be the same. If you've made a mistake with your sign, like most people do, and I mean 95% of the students would make a mistake here, this would end up being x plus 1, and you've seen now that, I made a mistake, because now I can't factor out my binomial term. And that's the next step. In other words, I'm going to factor out that, which gives me up here in the left, x minus 1 times what?
Times x minus 1.
It's left over when you factor out the x minus 1. Here's what you have. Factor out an x minus 1 from that expression.
X cubed minus 9x.
Now I'm not done. I can do a lot more factoring. What can I factor out of that second expression?
An x.
Okay, so now I have x minus 1 times x. What's left over?
X squared minus 9.
Keep going, because I can factor that.
X plus 3x minus 3.
Now I have a way to graph it. What do I do?
You plot the points. There are the x-intercepts.
Okay, and these are all multiplicity of 1, so the curve's going to go through everywhere that I plot an x, which is at 0, at 1, at plus 3, and at minus 3. Now what do I do?
Find the multiplicity.
I already did that. I know that it's an odd multiplicity at every one of these zeros, which means the curve goes through, but I still have to separate. I don't know if it does the following, or could it do this? I can't tell immediately which curve I've got. So what should I have done to begin with after plotting my zeros? Figure out the end behavior. In other words, I need to know whether it starts from there or there. It's either going to start from plus infinity or minus infinity. How do I tell? Plug in negative infinity for x. Down here where it's simplest to do, what are you going to end up with?
Infinity.
positive infinity. When we're dealing with end behavior, make sure you distinguish between positive and negative infinity. Because the fact that I'm going to deal, in other words, when I put negative infinity in for x, I get 4 negative infinities multiplied together, which is positive infinity, which means I start from that side of the x-axis. Now I know how to draw the curve. It's got to go through at that 0, it's got to go through at that 0, it's got to go through at that 0, and it's got to go through at that 0. And my right-hand end behavior is also positive infinity, which you would expect. If I plug in positive infinity for x, I also get positive infinity. So that's how you do it. You got to find the zeros, you got to determine their multiplicity, and you got to determine end behavior. Once you get those 3 things, plotting it is actually pretty easy. How do I divide that?
Long division.
Okay, what's my divisor?
X squared plus 1.
Actually, I believe you need to use a dummy variable. It's x squared plus 0x plus 1 is my divisor. My dividend is x to the 4th minus 3x cubed plus 0x squared minus 2x plus 1. Now we can do it the normal way. What's the first step?
Divide out x squared into x fourth.
What do you get?
2x squared.
No, just x squared.
I'm sorry.
Right? X to the 4th divided by x squared. That's the only one you're dividing, is the x squared into x to the 4th. Now I got to multiply that by all these terms. So that's x to the 4th minus 0 x cubed plus 2x squared. Now you can begin to see why we need all those dummy variables. Now what goes below here?
3x cubed plus 2x squared.
Minus. I'm subtracting. When I'm doing long division, I'm always subtracting. It's only in synthetic division where you're adding every row. Here I'm subtracting, so it's minus 3 minus 0. That's still minus 3x cubed. Now it's 0x squared minus 2x squared. That's minus 2x squared. And I bring down the next term. Stir and repeat. What goes up here next?
No. 1 more.
Oh, you're dividing minus 3x cubed by x squared. That's all you're doing.
So 3x.
Minus 3x. Multiply by all terms. And subtract. Minus 2x squared. This becomes plus x. Bring down the 1. Stir and repeat. And hopefully we will have no remainder. But let's see if we do. Yeah, we're going to have a remainder. Remainder is going to be x plus 3. So what's my answer?
X squared minus 3x minus 2 plus x plus 3 over.
Good.
X squared
In other words, that remainder is the remainder divided by the divisor, x squared plus 1. It's okay to write it like that. As long as that numerator is a lesser degree than the denominator, then it's okay to have that kind of a remainder. And that's how you do it. And that's a tough one because I had to add a dummy variable in the divisor and the dividend. Otherwise, it won't work. Now, whether I could do that with, I don't know if I could do that synthetically. I honestly don't believe I could. For one thing, I wouldn't know what to put in the box. What would you put in the box if you were dividing it synthetically? I guess the square root of -1. But that's not going to work very well. I don't think you can do it synthetically, to be honest. I might be wrong, but regardless. All right, this one, can I do this one differently? Let's do this one synthetically. Tell me what to write.
3 inside the box.
Across the top?
1, -10, and -24.
There's a missing variable there. Always look for those missing variables. That's what goes across the top. And I know you know how to do this. So what's my answer?
X squared less 3x minus x.
No, -1 with a remainder of that. There's my answer. In other words, that last number was not 0. Had it been 0, it means that x minus 3 would have been a factor of that polynomial. The fact that it's not 0 means it's not a factor, but that doesn't mean that I don't have an answer. I still have an answer, it's just got a remainder. That remainder is what makes it not a factor. In other words, there's a zero remainder theorem that says if you have a linear factor of a polynomial and you divide it, you must get a remainder of 0, otherwise it's not a factor. It's not a 0. 3 is not a 0 for this polynomial. All right. Find all of the zeros after finding the first one on your calculator. Let's start with B, because we're not going to have time to do both. And B is a little easier. First of all, do you know how to find a 0 on your calculator? Find one of them?
Yeah.
Go ahead and do it. Tell me what it is on B. But do you have an Inspire or a TI-84?
I don't have my calculator with me, sadly.
Here, I'll do it on Wolfram Alpha. What's the polynomial again? This is B?
Yeah.
What is it?
I don't have it on me.
Hold on.
I got it.
I got it now. 8x squared plus 17x plus 6. The beauty of Wolfram Alpha is it shows you what you put in case you make a mistake. Alright, I didn't make a mistake, so I just have to, and Wolfram Alpha also gives you the zeros. There are the roots. -3 and those two irrational roots. So we'll assume that you saw the -3 on your calculator, because your calculator is not going to give you the zeros. Your calculator is just going to show you this, and you're going to have to kind of guess, there's a whole number that's a root. And it's certainly easier working with the whole numbers first. Okay? So -3 is the root that I found on my calculator. Now what?
Use synthetic.
Of course it's 0. We knew that that was a 0. So what are my next two factors? There's one of them. What's the other one?
X squared plus 5x plus 2.
Clearly, since we saw the answers on Wolfram Alpha, I know that doesn't factor, and I got to use the quadratic on it. And the quadratic, what I don't like about this thing is I can't look at any other windows as long as I have this thing like this, and if I exit out, it disappears. So we'll save ourselves some time, and the solution to that quadratic is clearly these two answers here. -5/2 plus or minus √17/2. Those are the two solutions to that quadratic. And you can see there's the quadratic also. Wolfram Alpha kind of gives you all kinds of good stuff. They even factor that, they group that thing and factor it. Look what they did. They grouped together the x squared and the 5x, and they took an x out of it to get that next line where my cursor's pointed. I'm not sure why you would ever do that, but they do it. And then they give you all three zeros, and then they go on and they give you the domain, and they give you the range. They give you the derivative, they give you the integral, they give you the local maximums, the local minimums. They give you a lot. All right. What are you on the docket for? Is this it?
Yeah, I think so.
Yeah, you don't have any next week?
Nope, because
When's your test?
Monday.
Oh, okay. So you feel good to go?
Yeah.
Covered some pretty tough stuff tonight. I think you got it all. I think if we were to do problems like that again, you'd know how to do them. So, Nicholas, have a good weekend. Study hard. And good luck on your test. I'm sure you'll do fine.
Thank you.
You're welcome. Have a good one.
Bye.
Bye-bye.
You too.